Hello, this is Ms. DB, and today we're going to look at how to do some of the problems in the Chapter 3, Section 2 worksheet. You should also review the information in your textbook or watch the longer video that explains more about these types of problems. So first of all, in the first section here, we have this figure here, and it's got a bunch of numbered angles. And we are using that to name angles that are in the following postulates and theorems. So the corresponding angles postulate says that if two parallel lines, which we have marked with these arrows, are cut by a transversal, then the pairs of corresponding angles are congruent. Now, if you need to review what corresponding angles are, you should look back at Chapter 3, Section 1, which is where we learned about corresponding angles. One of the pairs is given to us. We have that angle 1 and angle 5 are corresponding. And if they are corresponding, this and their parallel lines, then the pairs of corresponding angles are congruent. So they wrote that angle 1 is congruent to angle 5. Now your job is to find the other pairs of corresponding angles. So look back and find what corresponding angles are and then complete 2, 3, and 4. Now the second one that we're learning about is the alternate interior angles theorem. That says if two parallel lines are cut by a transversal, then the two pairs of alternate interior angles are congruent. Now interior means that they are going to be between the pairs of parallel lines, here's the parallel lines, and on opposite sides of the transversal. So one would be angle 2 and angle 8. And you would write that angle 2 is congruent to angle 8. However, it's hard to make a congruent sign using word typing, so if you want to put equal, you can. Because if the angles are congruent, then their measures are equal, so we can kind of go to that step. And then you have to find the other one. And the next one is the alternate exterior angles theorem. So the same thing, you find the ones that are alternate exterior angles and write down that they are congruent to each other, because the theorem says if two parallel lines are cut by a transversal, then the two pairs of alternate exterior angles are congruent. And then the last theorem that we have says that the same side interior angles theorem says that if two parallel lines are cut by a transversal, then the two pairs of same side interior angles are supplementary. And again, if you don't remember what same side interior angles are, look back in 3.1, because same side interior are very specific. It's angle 3 and angle 8 because they're on the same side of the transversal, and of course they're interior. And the other pair is 2 and 5. Now the sum of those is equal to 180. The sum of their measures. So these are not equal to each other. So these ones are different. So when you write this, instead of writing that they are equal to each other or congruent to each other, you're going to write that the sum of those two will be equal to 180. That one is a little bit different than the other theorems and postulates. Okay, here's a proof of the alternate interior angles theorem. And we prove it also in the video, so you can go back and watch that. But this is how we proved it. We started with that we know that angle L is parallel to angle M, which they mark with these lines once you know they're parallel. And then we have to prove that angle 2 is congruent to 3. Well, we can start with angle 1 is congruent to angle 2 because they're vertical angles. That's this part right here. And we also already know that angle 1 is congruent to angle 3 because of corresponding angles postulate. And then you can put those two together with the transitive property to prove that angle 2 is congruent to angle 3. And you can see that whole proof in the longer video. And then here's a proof of the same side interior angles theorem. So you can look through that. Remember, theorems have to be proved before we can use them. And then here is a proof of the alternate exterior angles theorem for you to complete. Most of it's done. It's very similar to the alternate interior angles proof. So we know that the two lines are parallel. That's given. Using the vertical angles theorem, which two angles can we say are congruent by that? Only these two. And then angles 3 is congruent to angle 2 because they're corresponding angles. So the corresponding angles postulate, remember postulates we assume to be true. So this one is the corresponding angles postulate. And then we'll put those two together just like we did in the proof of the alternate interior angles theorem, which was using the transitive property. Go back down. And then you will be able to say that angle 1 is congruent to angle 2. All right, in the next section, you're going to find the measure of an angle. And there's more information on how to do this in the longer video. But first of all, you need to look at these two angles and decide what kind of angles they are. Well, these are corresponding angles. And what do I know about corresponding angles? If I have parallel lines, if you need to, go back to the top. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. Well, if the angles are congruent, then their measures are equal. So you can write an equation that says that 3x plus 23 is equal to 4x. And then you solve this and you get whatever x is, I don't know. And then you can plug that back in for the measure of angle ABC is 4x. And then once you know what x is, you'll just plug that in and you'll have your answer for the measure of angle ABC. That's not a negative, this is part of the line. So for 13, looks like the same thing. These are corresponding angles, so their measures will be equal. Let's look at 14. Now 14 is a little different. We have alternate interior angles. So first you have to identify what kind of angles you have, and then look back at the postulate or theorem. Alternate interior angles theorem says if two parallel lines are cut by a transversal, then the two pairs of alternate interior angles are congruent. So again, we can write a sentence, an equation that says that a plus 28 is equal to 2a, and we use that to solve for a, use algebra. This one's a little different. This says that we have same side interior angles. Same side interior angles are not congruent. If we have two parallel lines cut by a transversal, the same side interior angles are supplementary, which means that the sum of their measures is equal to 180. So the last one, you'll have a different sentence. You'll have that 133 plus measure of angle 1 is equal to 180. And you'll use that to solve and find what the measure of angle 1 is. Number 16, we have angle 1 over here, angle 2 over here. We have 60 degrees. All of these lines are parallel to each other. So we have lots of angles that will be congruent or supplementary, or not supplementary, but equal to 180. All right, so let's see. Measure of angle 1 is 2x minus 3y. Measure of angle 2 is x plus 3y. What do we know about angle 1 and angle 2? They are not corresponding. Let's do this. We know that the measure of angle 2 plus 60, these are same side interior. So the measure of angle 2 plus 60, measure of angle 2 is x plus 3y, plus 60 is equal to 180. And if I solve this a little bit, simplify just a little bit, I would get x plus 3y equals 120. And then I also know that angle 1 is equal to 60 because these are alternate exterior angles. So I have another equation that says that 2x minus 3y equals 60. So we have two equations, x plus 3y equals 120, and 2x minus 3y equals 60. We have two equations and two unknowns. This is a system of equations, and we can solve this using substitution or elimination. So I could solve the top one for x and get x equals 120 minus 3y, but these are already set up for elimination. If I just add these together, I've got a plus 3y and a minus 3y. I would get 1x plus 2x is 3x. The y's are going to cancel, and 120 plus 60 is 180. So we can solve this quickly for x by dividing both sides for 3. Once you know what x is, you're going to plug it back into one of your equations to find y. I would use this one. So x plus 3y equals 120. But now we know what x is, so we take what x is and put it in here. And then you'll subtract whatever that is from both sides. And then you'll get 3y equals something, and divide by 3, and you'll know what y is. And in the last problem, you have to find each angle measure. These are parallel lines, so you know that corresponding angles are congruent. So this would be 120. And then you know that same side interior are going to be something. So you'll be able to find what angle 3 is. You know that alternate interior angles are equal. So if this is 120, so is this. And you'll be able to find all of them just by giving one angle measure. There'll only be 2 answers for all of these. They'll all be either 120 or something else. All right, let me know if you have any questions. And remember to look back at your book for more examples and more explanations. Thanks a lot and have a great day.